Okay, let me announce the new speaker. It's Marcin from Pivotal. Marcin will talk about testing.
Correct.
Contract test in the enterprise. Thank you.
Okay, can you hear me? I guess you can. Okay, so let's get it started. Welcome to this presentation entitled Contract Tests in the Enterprise. We have quite a few things to talk about, so I'm going to waste some time to talk about myself. So I work for a company called Pivotal. Who has heard of Pivotal? Okay, quite a few people. So who knows Spring? Spring. So more people know Spring than Pivotal, which is typical. So Pivotal does Spring. We're doing Spring. And I work for the Spring Cloud team. Who uses Spring Cloud? Okay, that's saddish, but maybe after this presentation, everybody's going to be using Spring Cloud. So I lead those projects, Spring Cloud Sleuth. Who's heard of Spring Cloud Sleuth? Okay, good. Spring Cloud Contract, this is another project that I'm leading. Who has used Spring Cloud Contract? Oh, there are people who use it, awesome. And also there is an initiative called Cloud Pipelines that I lead. My Twitter handle is @Grzejszczak. Actually, people from Belarus can type it, can pronounce it, so you can just find me on Twitter. But if you have problems with actually pronouncing my last name, you can go to my blog, toomuchcoding.com, and find my Twitter handle over there. Okay, so let us simulate such a situation that I'm a developer working in a very, very sad company. Of course, your companies are great. You're doing stuff very well, I'm pretty sure. But let's imagine a situation where I am a developer working in a company that doesn't work the way your company do. So we've done a lot of mistakes. And this time, because we have a greenfield project, we've decided to do things properly. So, we have clean state, solid foundations, and this time we'll build things properly, right? The thing is that, after a couple of sprints, it turned out again that we've made some mistakes. So if you're a Java developer, you have to package structure your code in some ways. And it's very interesting because every single time, or like in a majority of, let's say, code bases, you can find packages like service, impl, API, DAO, and stuff like that. So if a developer was actually supposed to write a novel, in the same way the developer structures the code, it will look like this. Chapter 1, characters, chapter 2, locations, etc. And the best is Appendix A, which are twists, right? So we follow these guidelines, and we structure our code in a very structural way, infrastructural way, to put it in a more sad way, rather than structure the code around functionalities. We have a CI system which is stable because it's red all the time. Actually, 2 of the jobs are disabled because why not? One of the most important things in our company, in our CI system, is this plugin, which is called We Need Beer. So, whenever we're sad that the build is broken, we can click this and get a random GIF of a beer. So that's the only thing that works in our company, the plugin. So we can ask, okay, but what is your deployment strategy, right? We have CI. Now, what about deploying the stuff? So it's simple. It's a simplified structure, let's say, diagram of how we deploy software. There are 3 people in this company that know actually how our software is deployed. One is retiring, the other is on PTO, and the third one is dead. Okay, so there are 2. So if you ask us, where are end-to-end tests? So they're over there. That's what I know. And they take only 15 hours. So, of course, if they pass the first time, right? Because, of course, it's not the case in your companies because you don't have many end-to-end tests. You have everything unit tested, etc. But in our company, we have plenty of end-to-end tests. They typically fail because somebody steps on a cable and we have timeouts. But then we have to rerun them, right? That's a normal thing. The test fails, rerun until it passes. So that's what we do. We're agile. That's the most important thing. We're agile, and we care about the quality. So we're Agile, which means that we have sprints. So we have a 6-month iteration. This is our sprint, 6 months, right? Because that's the idea of Agile. And typically, the first 5 months is the rear of the horse, and the front is, the last month, because, we have deadlines, right? So that's what we do. But the most important thing that we are Agile. We react to changes as fast as possible, which in our case is 6 months. Now, this is our architecture. So let's say, starting from the left, we have an insurance service and audit service talking to a legacy service. So today I'm going to show you how we work around the legacy service that talks to a customer rental history service, whatever that is. The whole communication happens over HTTP. And the thing is that the customer rental history service talks to a payment processor and the mainframe. And, it's actually hard to test the legacy service because the downstream dependencies, the downstream services are problematic, especially the mainframe, right? So I don't think we properly understood in our company the way the tests should be done because, I read some things about testing and I heard about unit testing. And from what we understood in our hypothetical company is that unit tests means that we have to have unit amount of those tests. So we have a couple of unit tests. We have more integration tests. We have a lot of UI tests, right? And because I'm terribly, disastrously awful with graphics, this is an idea of manual tests flooding out of the pyramid. So these are, we have that many of them. So we have hundreds of testers clicking around our app, right? So this is our current state of things. Inside, I feel that something is problematic. So speaking of the testing pyramid, I've decided to, do something about my knowledge of tests. So I went to the Wikipedia, and I read about unit tests. What are those? So it turns out that it's not exactly what I thought, that you have to have unit number of those tests, or that you have to test a single class only. It turns out that you can test individual units of source code, sets of one or more computer program modules. Insane, right? So for example, if you have a factory and a builder, and they always work together, why would you test only one or only the second one? Maybe you should test them together, right? So that's what I learned from the Wikipedia. So I then said, okay, so we have to completely change our pyramid to have unit tests only, which is a great idea, but sometimes you can have problems, right? For example, obviously, unit tests are passing here, but something is wrong. The same thing here. You can open the window. This is my favorite. The dryer works very well. Although, in general, it can be problematic to do something with your hands here. So yeah, unit tests. If you write only unit tests, you can have some problems. So I said, okay, so that didn't work. Let me do some integration tests. So what are those? So we have the unit tested code. We group them in larger aggregates, and we apply the tests, right? Okay, that sounds very good. So I don't need the unit tests, right? I'll remove them. And I will write only integration tests. So as you can see, I'm running 2,000 tests. 2 of them failed. And this is actually real footage of somebody running the tests and seeing the final result. Yeah, that's... So one of the solutions is actually not to have any tests. Then you don't get frustrated, right? But if you have integration tests only, we come back to the problem that the feedback loop is very elongated, so to say, right? Because, you have to wait a long time to actually see that one of your tests is failing, which is sad. So end-to-end, right? What are those? So let's say we have the unit integration test components, and we start the apps. We have some sort of an environment where we set those apps. We communicate with the database, network, hardware, all the stuff, right? And then we do the testing. And we come back to this problem, right? So 15 hours of end-to-end tests, very flaky, very brittle, etc. So there has to be a better way to solve those problems. Now we have some, let's say, theoretical background. Let's try to tackle the problems that we have in our company. The customer rental history service is unreliable. Right? So if we're talking about this communication between the legacy service and the customer rental history service, it's problematic. It's unreliable because of the downstream dependencies. So what we did in the legacy service, we decided not to call the customer rental history service. We decided in the tests to create a fake response, right? So who has been doing any stubbing of other services? Okay, quite a few people, good. I've been to one of the conferences where I was doing a presentation, and I asked this question, and nobody raised a hand. Then I asked, who is doing tests at all? Nobody raised a hand, so this was the problem that I guess should have been tackled first, right? But somebody raised their hand, which is good. So we have the hard-coded stubs, which are problematic again. Why? Because we have 1,200 lines of JSON response from the customer rental history service. Now, remember, we, as a legacy service, are calling another app, and we have created the stub, right? We, as legacy service, as a client. So whenever the customer rental history service is changing, we need to update the stubs every single time to keep that in sync. What also we did is that we don't really send out a request, we just fake out a response, immediate response from the JSON, right? So if we have let's say, an interface in Java that wraps a call, a REST call, HTTP call to another service, we mock it out with Mockito or whatever else to immediately respond with an object. So we don't test the actual connection and HTTP calls. So if you're doing things like that, and I saw that you do, maybe you haven't seen it, but you have a gigantic problem. Why is it so? Even if you test the HTTP communication, whatever you have on the test side is the client teaching a stub how to behave. So if you're a client and you're using a stub, some sort of a tool like WireMock or whatever else, and you teach this fake HTTP server to, let's say, respond with OK if I shoot a request at foo, it will exactly behave as you told it to, right? Because you told it how to behave. So you send a request to foo and you get unicorns because everything is fine, right? If you put random letters there instead of foo, and you teach the stub to behave like this, your test will pass because you told it how to behave. But in the reality, if you send a request to foo, the customer rental history service might not have had this endpoint, right? So your tests have passed, your production didn't. So that was the problem of hard-coding stubs. So you can say, okay, but I have to do it because I call an app that I don't control, right? So let's say I'm the legacy service, and there's the customer rental history service, another app in our system. The other team doesn't like us. They have full backlog. You always have a full backlog, right? So if you go to their product owner and say, hey, we need some sort of a stubbing mechanism that is reliable, they will say, okay, we'll put it on the backlog and we're going to do it in 285 sprints. So we're in such a situation. So the question is, what can we do to make our life less miserable? What you can do is proxy the calls. What does it mean? Let's say that we have a project where we write a test that calls the customer rental history service, a real app that is running, right? Because typically, if you let's say you have an end-to-end test environment, one that has a name that was cherished for ages, like 200 years ago when somebody set up the server, they set up the environment for end-to-end tests, right? And you have when you log in, you have a gigantic sign, don't touch anything. So let's say that we are on such a server. And there we have the customer rental history service. So what you can do is you can write a test that will call the real customer rental history service every 5 minutes, every hour, every day, every week. It depends on you. But you don't call it directly, you call it via a proxy. Why? Because the proxy can record the traffic. It will record your request and a matching response, right? So you send a request to foo at the customer rental history service, and it returns OK. So the proxy stores get foo, returns OK. And that way, it can be then transformed into a stub, right? You can get such a stub. So what I did is I created such a test that calls an API of a company called Stripe. So I've managed to send a GET request to V1 charges. So this is given this request. This response was sent back. So it happened. Stripe responded in such a way, and I've managed to store it. right? So it's post factum, it happened on production. So, okay, let's say I have this test, I've managed to create the stubs, now what? So what I can do in the legacy service is I have some sort of an integration test that would like to, verify if I can call the customer rental history service. Since I've managed to create the stubs from the proxy, I can run the stubs inside my integration test, and I can exercise, let's say, my tests against the stub, right? It comes from production. So what is the outcome? I have fast feedback from quite reliable stubs. Why quite, right? Because the stubs are valid only the moment I've executed the test. So if I'm running the test, I called the real production app, and I'm going to run the test next time in a week. Within the week, something might have changed with the production code. So it's better than actually doing it manually, but we can have problems that we'll try to tackle in the next parts of this presentation. The problem that we can't really solve is that the other app doesn't want to really cooperate in the way we would like them to cooperate, right? So we have to somehow, do our best to save our sanity and, improve the quality of our tests. And another thing which is very interesting is that, of course not you, but developers forget that their decisions cost money, right? So if you go to, a conference, you come back from the conference and you've heard about this fabulous NoSQL database that is like a silver bullet to all of your problems. When you go back to, to your company and say, we need this database, your decision can cost a lot of money, right? So if you start doing contract tests in such a way, for example, I've shown you, you can spend less money on end-to-end tests. Why? Because if you can't communicate with those stubs that come from production, for sure you will fail on end-to-end tests, like beyond any doubt. So don't even start running them. First fix the tests. Okay, so we've dealt with the app that we don't control. How about those that we do control? So the hard problems that we're trying to solve is how can we add something to a service that exposes an API without breaking the clients? That's pretty easy because you just add things, right? It's additive. It's not breaking. It's not a breaking change. How about removing something from an API without breaking the clients? Actually, let's even go further. If you are a developer of a service that exposes an API, how can you actually know who is using your API and how? Of course, doing a 6-month iteration is great, but how about, leveraging contract tests to improve the let's say, the continuous delivery quality and have a faster feedback cycles, shorter release cycles. So in order to do that, we have things like service evolution patterns. Who has heard of those, service evolution patterns? Okay, nobody. So that's something new. So there are things like tolerant reader. So it's an approach where, let's say, if you send a request or you receive a request from an outside world, and there is a property that you don't understand, just don't throw an exception, right? Most likely, if you're using Spring Boot, that's a default thing. You don't even know about this, but you could theoretically throw an exception where a field that you don't know was received by you, right? So extract only what is needed. Schema versioning, I guess you all know that. So if you want to, introduce a new thing in your API without breaking your clients, you had a V1, then you're adding V2. Of course, this is, let's say, a poor man's version, because if you're using hypermedia, you don't have this problem because you reverse the issue. So your API tells the users what they can use and how. Extension points, one of my favorites. So I worked once in a company where we had to communicate with a government API, and they were providing fields called, for example, EX 10,899, and then you had a gigantic, let's say, manual to see that it's client name, right? If you have a, let's say, boundless map to which you can put whatever, you can say that you can extend the schema endlessly, right? Yeah, you can do it. Another option is to do consumer-driven contracts, and what is that? We're going to see in a second. So first, some terms. So if I say a producer, I mean a service that exposes an API or sends a message. Consumer is a service that consumes the API, so sends a REST call, for example, or listens to a message from a producer. So let's say listens for messages from a broker. So what is this mythical contract? So contract is an agreement between the producer and the consumer on how the API and message should look like. It's not a schema, because as a consumer of the API, I don't care that you have 258 fields there on the request side, because as a consumer, I would like to use only the 2 for this particular use case of mine. So this is the change. When we're talking about contracts, we're talking more about scenarios of usage rather than all the possible request fields and response fields. You have different types of contract tests or contract testing approaches. You have provider contract. So let's say we have 2 clients, A and B, and let's start from the service side. Let's imagine that we have a Twitter API or whatever API, like a public API. So the provider of the API says, hey, if you send me a request, I require 3 fields to be there: a triangle, a circle, and a pentagon. So the clients of this API say, okay, I mean, I don't really need, like, I don't care about the triangle, so it would be great for me actually not to send it, but okay, if you need it, I will send it to you, right? So the provider says, this is my API, you have to use it like this, right? This is provider contract. Now, consumer contract is something different. So it starts from the consumer side. And let's say that client A says, if I send you the triangle and the circle, respond with 200, okay? Client B says, if I send you a pentagon, respond with 200. Client B says, I don't care about any triangle or circle. I don't even want to know that it exists, right? So each of the consumers can use the API or parts of the API in a different way. And now the service side has to say, okay, client A needs the triangle and the circle, client B needs the pentagon, so I have to support all 3 options. Right? So it's inverted, so the clients say explicitly how they want to use the API. So now we have the consumer-driven contracts approach, which is essentially a process that involves a conversation, unfortunately. Right? This is why we've gone to IT, in order not to talk to people, and now we have to talk to people, right? And another problem is that there is no real solution to talking to people, right? You can't use an automated approach. Sometimes you just have to talk to people. And here, the conversation happens via a contract. So consumers say, dear provider, these are our expectations. You can take them and run those expectations like a test on your side. So if I tell you that I need a triangle, if I'm sending you a triangle, respond with a circle, you can take my expectations, run them against your code, and see if it's actually true. So there's a conversation going on, and let's say the consumers have their consumer contracts, and the sum of consumer contracts is actually a provider contract. But in general, it's a process, it's a conversation. And there are, of course, tools to help you with the process. So what are the benefits of the consumer-driven contracts approach? First, the service providers align themselves with the business goals of the consumers, right? Because the consumers say exactly how they want to use the API. It's actually funny because the name consumer suggests that they consume the API. Never actually a producer of the API calls it self, right? So it's the consumers that know how to use the API, really. If you're the service provider, you can see that, for example, those clients use the API in such a way, right? If you use consumer-driven contracts, you can evolve the services much faster without breaking stuff around, because you have automated approaches to verify if the contracts are met. And you can also leverage this approach when you're doing continuous delivery or deployment or even CI. So it's matching perfectly any automated process you're doing. So we had our fabulous pyramid. So let's try to change it to something better, at least in our case. So we have a lot of, actually, maybe for you it's boring because you all do this, but for sure, you know, there will be some people that have never seen it. So you have a lot of unit tests, then you have contract tests with service API tests. So one more thing, contract tests are not supposed to change, like replace your end-to-end tests, right? So inside the contract tests, you don't want to test the functionality, you want to test the semantics. So we want to test if we can communicate. We don't want to test if all the possible features are working fine. And then, if at all, you can have end-to-end tests and UI tests, but consider actually theoretically replacing them at all, like removing them. And manual tests at the top also, if possible, automate those. Okay, so we're at a conference. I had to say microservices, right? Because if you're going to a conference, there has to be something related to microservices. So when you're migrating to microservices, you might have this problem that, who, by the way, is in process of migrating to microservices? Okay, so who has migrated to microservices? Who doesn't want to migrate to microservices? Who doesn't care at all, like 0? Okay, good. So yeah, so when you're migrating to microservices, typically what happens is that you have a monolithic application in the middle that happens to be the source of truth, source of data, right? Because from that, you want to split out pieces of, let's say, some bounded context and put them aside, right? So until you do this, the monolith is the source of truth. And from the point of the monolith, you don't even know if you can change the API. So that's what typically happens. So let's say that our monolith is the legacy service, and there's a lot of services around that started to pop up. But the legacy service still holds the information about the user. So maybe it rings a bell, but every single of the services has an integration test to see if they can, for example, fetch some information about the user and do something else. So every single service mocks out the same call to get user. So every single service repeats the same work and does it in such a way that it makes no sense. Because all the services are cleaning the stub on their side. So we come back to this first problem we had. So the moment those stubs were created, they might have already been outdated. So what can we do about this? Yeah, so stubs on the consumer side are not reliable, and we've wasted time on writing those stubs. So let's try to solve this problem. Let's define a contract, right? Let's try to somehow define the way we would like to tell the provider of the API how we'd like to use their API. So let's say that we're using, who uses Kubernetes? Okay, there are some people. In general, the best language right now out there is YAML, of course. So let's use YAML as well. Let's be we're at a conference, so we have to use YAML. So let's say that we're going to define an example of a request, an example of a response. So we say, given a request with a method get, that will be sent to a URL check, a method post, sorry, that was going to be sent to URL check with certain body. Now body, we have let's say we have a JSON body that is being sent. So JSON can be essentially a map, right? So what we say is that if inside this map the age is 10 and the content type is application JSON, please respond with status to 100, body status not okay, a JSON structure, and headers should be content type application JSON on the response side, right? So we express certain scenario of usage. Okay. So are we any closer to anything better? Not really, because it's just a contract defined on a sheet of paper, right? What we want to achieve is to send this expectation to the provider and say, can you assert that you're valid against this contract? This is one thing. And the other, could you please somehow generate stubs for others to reuse? So we want to invert it, right? We don't want the clients to create the stubs. We want the provider to generate the stubs. So we would like, for the legacy service, given the contract, have contract tests and generate stubs. So we would like to have an approach where we have the contract, we run the build of the project, we generate or ran tests to verify if contract is met, and we generate reusable stubs. So let's say we're using some sort of a framework that actually generates those tests. And here we say, given this request, which contains the age, the content type, and the post method, when the request is sent, assert that the response is correct, right? So whatever we put in the contract, we want to verify on the producer side if that's actually true. Because if the producer doesn't have such an endpoint, we would like the producer's code to break, the test to break. Let's also generate a stub from the contract. So we said, given this request, URL check, method post, content type application JSON, an age matching some sort of a regular expression, for example, send back status to 100, status OK, and application JSON on the response side, right? So we've managed to generate tests and generate stubs. So let's turn it around. Let's say that we have some sort of a stub storage. We have our monolith that defines the contracts, or there are some contracts exercised against this monolithic service. So we run the build, we generate the tests, we generate the stubs, and we upload them only after the tests have passed to the stub storage. And now all of the microservices can fetch the stubs from the stub storage. No longer do they actually write them themselves, they're fetched from a common location. Does it make any sense? Okay. So as a consumer, I would have my tests. I would have some sort of machinery that would fetch the stubs from the stub storage, run the stub server, and then when I run my test via some sort of a test runner, I would send a request to the stub server, and I would get back a response, and then I would see if my tests are actually passing. So what is the outcome? We have fast feedback from reliable stubs. Why are they reliable? And previously we had quite reliable. Because here, whenever the provider sees that the contracts have changed, the code gets built, immediately new stubs will be uploaded, right? So if there's a new contract, it's getting committed and pushed to Git, the producer code is being built, the new tests are generated. When the tests pass, the stubs are generated, and they're pushed to the stub storage. So then, as a consumer, the next time I'm being built, I will fetch the latest stubs, and I will break, for example. Or I can just reuse them as fast as possible. Again, less money spent on end-to-end tests, and actually, I, as a consumer, don't have to write any stubs, because they come from the producer side. Okay, so what about new shiny microservices? Let's talk about API creation, because it's the consumer that actually uses the API, and I've mentioned that. Well, it would be great, especially if you're a front-end developer, to take part in the creation of the API of the producer. Because typically you have to really stretch your head to actually combine all the pieces that are required on the producer side that you should actually create on the front-end side to send a request. Actually, come to think of it, the producer's API should change only when the consumer needs to, or if you're removing a deprecated API. And this is where consumer-driven contracts come into play, because we've seen producer contract a second ago, now consumer-driven contracts. So let us assume that we are the consumer team, and we have some sort of a Git repo where we store all the contracts from our company. And we're trying to work with an API of a team that's not yet assembled. There's no production code. The team will be set up in 10 months. So what we do as consumers is we could actually for 10 months do nothing, but it's not a good idea. What we can do is try to tell the future producer what kind of contracts we would like the producer to have. So we have a tree-like structure where every single producer has their folder in which every consumer of their API can describe their expectations. So producer 1 has a consumer called producer 2. Producer 2 is used by producer 3. And for example, nobody's calling producer 3. Right? So this is how you can, let's say, via a convention of folder structure, define who's using who. So now the consumer says, okay, let me play around with the API, creates a YAML that represents the API of the code that doesn't exist, right? There's no production code of the service. Interacts with the YAML, and then the consumer says, okay, I think I like the API, even though the producer code doesn't exist. Then, to some local stub storage, converts the YAML into stubs, as you could have seen a second ago, and generates writes some tests locally and plays around with the stubs, right? So without even having the producer code whatsoever, the consumer is able to prototype the API, create the stubs, and play with them locally, again and again and again. This is why consumer-driven contracts can be called TDD on the level of architecture, because the consumer creates some sort of expectations, plays with them locally, runs some tests until the consumer is happy with the API. Then the consumer sends a pull request, time for a PR, and then after 25 months when the producer team was set up, the producer says, oh, someone has requested that I have this API via the contract, right? So what will happen when the producer, let's say, sets up the project and does clean build, is that the tests will be generated and they will fail because the producer hasn't yet started writing any production code. But already you have generated tests from the contracts that will verify if your API looks the way it was presented in the contract. So the tests are failing, then the producer fixes the tests, files the pull request to the repo of contracts, and merges the pull request to master. Right, so both sides manage to communicate. Okay, let's go to the CI system. The producer team has merged the production code. The CI builds the producer, and there are two artifacts generated from for the CI system, which is the binary and the stubs. Right? For example, if you're using Java, it's going to be a jar with your application and the stubs. And then, if you're a consumer, what you can do is essentially say, okay, no longer do I want to work offline. I don't want to prototype the API anymore. I would like to fetch the stubs from a remote location. And this is exactly what's going to happen when the consumer runs the test. The stubs will be fetched from the stub storage. Great. So you can say, okay, did you say that all contracts are stored in a single repo? You could do this, which means that if you have all the contracts from all the company in a single repo, you could generate the documentation of the whole API you have in your system. And this is an example of an ASCII doctor-like documentation that iterates over all the contracts and prints out a nice documentation of your API. I said that you have a tree-like structure representing that there is a producer that has a consumer, and the consumer is consumed by somebody else. Could you sketch the graph of dependencies? Yes, you can. Because you have a tree-like structure, you can run a simple test that will assert the links between the projects, and here you can see that, for example, oops, what happened? There you are. So you can see that yet another consumer is calling bar service, and bar service is calling the beer API producer external, whatever, right? So you can sketch the whole graph of dependencies in your system. What about messaging? Who's using messaging? Okay, quite a few people. You can have exactly the same problem in terms of testing your messaging API. So in your test, what you typically do is you create a message that is sent to some sort of a, in-memory broker, in-memory queue, something like this. So you create the message, you send it to a topic bar, for example, and you consume it in your own project, and the tests are passing. It's great. What happened to me once in one of the companies is that we sent the message to a different topic, and the feature was working fine, but not a single message was actually consumed, which is depressing. So that's one thing. So we would like to actually verify if two parties can actually talk on the same topic, right? Another thing is that you can have a problem with, even if you have a good topic, you can have a problem with deserialization. Because there are frameworks that actually don't deserialize and serialize your objects when you use some sort of a test in-memory broker or test queue for the sake of your messaging tests. So we could also do exactly the same approach, but we could define a contract using YAML, for example, where we say that on the producer side, we want to see if I trigger the message. So you can say that the message should be triggered by some method, for example. I want to verify if the message was sent to a proper destination, and can I deserialize it properly. And on the consumer side, you can say, do I listen at the proper destination, and can I deserialize the message properly? Okay, you can say, I mentioned Java. What about the Polyglot support? So let us assume that you have an Node.js application that talks to some HTTP service. Let's say I send a request. I get status undefined because it's JavaScript. So what I can do is since we are at a conference, one thing that happened is I said microservices. The other thing that should happen is that I say Docker. So now it's time for Docker. So let's say we have a non-JVM application which is going to consume some other application, and we would like this non-JVM application to actually leverage some stubs. So what you could do is, for example, use a Docker image that would connect to the stub storage, start the stubs in memory, or like actually inside the Docker image, And then when you run your non-JVM application, it could send a request and talk to the stub executed inside the Docker image. And then you get a better result. So this was on the consumer side of a non-JVM application. What about the producer side? Can I generate tests for an app in any language? Yes, you can. So let's say that you have an application, and it's in Node.js again, and it creates the YAML contracts of their API. So you can create or run a Docker image that will have the contracts mounted, and it will assume that your app is running. So once the contracts are mounted, the tests are generated inside the Docker image, and they are executed against your running application, the tests, right? So if you say that you have 2 endpoints, we will verify that by generating the tests and calling your real application. Once the tests have passed, we can push the stubs, the generated stubs, from the contracts to the stub storage. So I guess this is from my side. Time for questions. And before we go to the questions, one more thing. What we have managed to build right now is essentially a framework called Spring Cloud Contract, so the one that I'm doing. The server, the HTTP server that we're using under the hood is called WireMock. The DSLs you can leverage to actually create the contract is either Groovy or YAML. We will allow Kotlin in some time. The moment we have some time to actually, finish the pull request that has been there for a year or so. We support messaging. If you're using Spring Cloud Stream, Spring Integration, Spring AMQP, it works out of the box. Apache Camel as well. But you can also extend it. So if you have some other framework that you're using, you can implement a bean and or an interface, and that's going to work. We support dynamic pieces because sometimes in a contract you have a UUID time. So we want to, make it more dynamic. We support stateful stubs, so essentially scenarios. For example, you want the stub to know that it's in a given state, and then you want to transit this state to another. We allow storing stubs in Git, Nexus, Artifactory, Packed Broker, and you can also extend that. And there's much, much more. Please read the docs. It's Cloud Spring IO, Spring Cloud Contract. Disclaimer. Okay, and that's it from my side. My Twitter handle is @Grzejszczak, and time for questions, I guess. So before the questions, one thing. Who thinks it makes any sense, what I said? Okay, a couple of people, good. So it wasn't that bad. Okay, time for questions.
Any questions? Second one.
Maybe strange question, but is there any way of using the Spring contracts out of the Spring architecture or Spring stack?
So if I understood correctly, you said that we're using Spring Cloud Contract and you want to use it in a place where there's no Spring. Absolutely, you can do it. Why? Because on the producer side, you just have to tell us when the tests are generated, they extend a base class of some sort. Because typically you have to set up, some sort of a context, whatever that means. One of the things you can say is, hey, I'm not using any Spring mock MVC things, no Spring stuff. So what I want to do is I'm going to tell you the IP and port of my app and just send the requests there. So what you can do, and actually I've managed to record a course on Pearson about Spring Cloud Contract, and over there I show an example using Javelin. So I have a Javelin application, and it's running. So in the base class I say, please run my Javelin application. This is the port of that app, and the tests are generated, ran against a running application. So you don't need Spring whatsoever. You just have to, in the plugin that generates the test, say, I don't want to use the mock MVC thing from Spring. I want to use an explicit thing where I'm going to explicitly state how to connect to my running app. So that's on the producer side. On the consumer side, you have two options. So if it's, one is Docker, but if you're in JVM world, you can use a JUnit rule. So you don't have to use any Spring stuff, no annotations. You just say stub runner rule, and you say, please run this stub running at, at this port, do this, do that. And regardless of your framework, it's going to start in memory the wire mocks for you, fetch the stubs, and do all the stuff. That's a very good question.
Thank you, Marcin. My question related with messaging. You say then we use messaging, we can get problems with serialization in deserialization, right? And then we can avoid this problem. Then we use some schema registry servers, like our schema registry and something else. Does it mean that we can avoid contract testing? Then we use these registries or not?
So if I understood the question is that if you're using a schema registry, then does it make sense to use contract tests at all? Because you have a schema registry and you won't have the problem with deserialization and serialization, correct? That was the question. So yes and no. If you're using a schema registry, then indeed you don't have a problem with deserialization and serialization, but it's a schema, so it doesn't tell you actually how to use the messages. It doesn't allow you to, from the consumer side, again, I have to know about all of the entries in your message, like that you have such fields or like that the payload looks like this, right? For example, from my point of view as a consumer, again, like with the triangle, pentagon, and circle, right? There are different people that might have different needs. But it's much better to actually use a schema registry than do nothing at all. Another thing is that even though you're using a schema registry, you might have a problem that the framework as such that you use for messaging has just doesn't do this realization. So it was, I think, a year ago that Spring Cloud Stream had this problem. And actually Spring Cloud Contract, when it was using Spring Cloud Stream, it didn't catch a bug that I afterwards found running the Spring Cloud Contract in a production way. I don't want to go into details of that, but Spring Cloud Contract can also be executed in such a way that it will send your stubbed message to a real broker, right? Because this is another thing you can do. And over there, I found an exception. I found a bug. So the question was why the test binder of Spring Cloud Stream didn't catch the exception, right? Didn't catch the bug. And it turned out that back then, Spring Cloud Stream took an object of your POJO, of your message POJO, and just passed it on without deserializing and serializing it. So there are frameworks that can have problems or challenges, to put it in a nice way. But now it's fixed, so don't worry. Any more questions? Oh, there's a question.
Hi, Marcin.
Hello.
I was a little bit wondering regarding duration of your sprints. It's really that duration has 6 months?
I didn't understand anything you said. Once again.
Yeah, sorry. You said that duration of your sprint was 6 months.
Oh, yeah.
Yeah?
It was 6 months, yes.
I was a little bit wondering regarding it. Could you a little bit describe your sprints? I don't know, how many tasks do you have in backlog? How do you estimate stories? Okay. How many story points do you have? Do you have red or something else?
No, so the question was about this thing at the beginning that I mentioned that we have a 6-month sprint, right? So it was a joke, obviously, but actually it wasn't, because I was working in one company that indeed we had a 6-month iteration. And it's a funny story because I was working as a, let's say, semi-consultant because I was like, let's say, sold to a project, right? It sounds terrible, but that was the case. And the project was described as having Agile. And I said, oh, great, I want to work with Agile. And then I went to the project and they said, yeah, we're Agile and we have a 6-month iteration. And by the way, I'm the product owner, the guy said, and I'm going to stand beside you and take a look at your monitor at what you're doing. So I said, it doesn't sound like Agile. And they said, yeah, but nobody would, want to come to the project if we wrote the truth. So that was the story behind the image. Unfortunately, it's true. So that was a joke, obviously. But in terms of Spring, how we do stuff, we don't have 6-month iterations, obviously. And actually, maybe we do. No, it depends. So since we are doing, libraries essentially, we are a little bit beyond the scope of, like pure Agile. We're more Kanban based, so to say, because we have some tasks and we prioritize them. But our release cadence is not related to the fact that we want to release every day. We do release every day with snapshots, right? Then you can, test those snapshots, etc. But I'm pretty sure you would be extremely angry if Spring had a release every day of a new version, and you would have to bump, right? And from our perspective, with such a release every day, we would have to support that particular release for a year or so. I don't really remember. There's a certain period of time where we have to support those things. So maybe doing open source. Of course, it depends, because, for example, Mockito releases all the time. They have a continuous delivery, or actually delivery or deployment. I don't remember if they're releasing. I think they're releasing GA versions very, very frequently. So it depends on the project, obviously. But I don't think that projects that are doing, let's say, open source projects, their release cadence, the way they work, are actually heavily applicable in business, let's say, applications. So the best project where I worked with Agile, and I was really extremely happy, was the one that we initially had a 2-week sprint, but we were very bad at estimating, terribly bad. So the initial thought was actually to make that sprint become a month, but what we actually did was we changed it into a week. Why is it so? Because it forced us to estimate even better. And we were deploying, actually delivering, releasing software very frequently. It wasn't like that we, So back then we did it every week, like a release every week. But we then managed to migrate from, let's say, this approach to Kanban. And we've managed to deliver our monolith every day at 9 a.m. We had a Jenkins job with a cron. And microservices were delivered with every merge to master. So I don't know if that answers your question at all, but hopefully it does. Any more questions? Do we have time for more questions?
Unfortunately, we are out of time.
So if you have any questions, you can approach me or find me somewhere around here, and thank you very much.